All right, so here we go. We are going to talk about radicals or square roots. All right, and we're going to talk about simplifying. Okay, when we talk about radicals or square roots and simplifying, that's when we have to put it in its lowest terms but keep it exact. So for example, if I have the square root of 18, okay, for it to be exact, I can't take the decimal. The decimal is a never-ending decimal. It's irrational, so we have to simplify it. When we simplify, we call our friends. If you recall, we broke this 18 down into 9 times 2. And the 9, if we break 9 down into 3 and 3, we cross out the 9. Anything that has 2 factors comes out as one group. So since there are 2 3s, they're going to come out as a single 3 to the outside of the radical. And staying at home is 2 because it doesn't have a friend. Does everybody remember doing that? Yeah? Did you get a chance to do it with Mrs. Lacey last year? You did? Okay. All right, good. So that kind of helps you know where I'm going today. All right, so that's what we're doing is we're simplifying square root. So straight up square root, when you're just simplifying it, you break it down. I want to remind you, what if there's something on the outside of that square root? So let's say we have 3 square root 50. Okay? And I want to simplify that. We're going to break 50 down, and we can do 5 times 10, right? And then 10 can be broken down into 5 times 2. I'm going to cross my 10 out, so I know I broke that down further. So this time I have a group of 5 that can come out. Now, I always said back in algebra, when they come out, they multiply the fun. When they go out to the party, so to speak. So when this 5 comes out, it's going to multiply with the 3, and the 2, again, is left at home without any friends. Okay? Talk about one like this. How about we have the square root of 32. Okay? 32 is going to break down a lot. Let's talk about this one. 32, we can do 8 times 4. 8 can break down into 2 times 4. And 4 breaks down into 2 and 2. Cross that out. And this 4 breaks down into 2 and 2. Now, I like you to go all the way down because eventually we're going to use this for other stuff. Now, we circle any pairs of 2s. We have one group of 2s, 2 groups of 2. Those groups, when they come out as a single 2, but they're going to multiply together. So we end up with 4 square root 2 left behind. Try another one. Say I have the square root of 72. No, actually, let me change my mind. Sorry, guys. Instead of 72, let's go with, let's go with 72. Let's talk about that one. All right, 72 is going to break down a lot. 9 times 8, right? 9 is 3 and 3. Again, I like to cross it out if I broke it down so I don't look at it again. 8 is 4 and 2. And 4 is 2 and 2. All right. So again, I have this group of 3s, and I have a group of 2s. When they come out, again, this one's coming out as one group, and this is coming out as one group. When they come out, we're going to multiply them together, and what's left at home is the 2. Now, what if there was something else left in here? Then we'd have to multiply those together to stay home. Okay? What about this one? What if I have a negative 12? Does anybody remember what we did with the negative inside the square root? If it's a negative, This right here makes it imaginary. Do you guys remember imaginary? If it was imaginary, then you wrote an I for it. Okay, so we're going to talk about that a little bit more. So if I have negative 12, 12 itself is all I'm looking at. That breaks down to 4 times 3. 4 is 2 times 2. Okay, so that means I have a group of 2 that comes out. I have a 3 that stays home. But anytime it's negative in there, it's imaginary and it doesn't exist. So we're going to write an I right here. Okay? All right, let's try one like this. Negative 2 square root 200. All right, so 200, we can do a lot of different things with 200. You can go 20 times 10, and 20 can break down into 2 times 10, cross that out. You'll notice we have a set of 10. We can actually stop right here instead of breaking them down if we wanted to. If you decided to, we have a group of 10s that get to come out. And when it comes out with the negative 2 out here, that's already on the outside, so that's not imaginary. I'm going to bring that 10 out to multiply with the negative 2, and I get negative 20 square root 2. All right. How about, let's do some variables in here, okay? So let's say I have the square root of 24 x squared y to the third. We need to simplify. 24 breaks down into 12 times 2. 12 breaks down into 3 times 4. Cross that out. And 4 breaks down into 2 and 2. Okay? So looking at this, I have a group of 2's that get to come out. So a 2 goes on the outside. Staying at home is a 3 and a 2. So again, when they stay at home, they multiply the fun. So that becomes a 6. Let's talk about x squared. That's 2 x's. So I have a group of 2 x's that get to come out together as 1x. And I have 3 y's. So I have one group of y's that get to come out, but that means I also have 1 y that has to stay home. All right. Let me try another one, and then we'll get into the hardest part of the radicals today. So let's try this one. What if I have a to the third, b to the fourth, and c to the eighth? All right. So I need how many groups of a's can come out? There's 3 a's in here. One group of 2 a's can come out. Staying at home is going to be one single a. We have 4 b's in here. So how many groups of 2b get to come out? We have 2 groups of 2b's, so I have b squared. Are there any b's left over? No. C to the 8th. I could write those out. 1, 2, 3, 4, 5, 6, 7, 8 of them. I have 1 group, 2 groups, 3 groups, and 4 groups. So I have 4 groups of C. That comes out as C to the 4th, and I don't have any without a friend. So this would be my final answer. So we've talked about simplifying them, but the hardest part is if you simplify them and they're in fraction form. So simplifying in fraction form. All right. So 1, I want you to reduce the fraction first. Okay? If you can reduce the fraction, reduce the fraction first. Step 2. All right? Simplify the radical. And we're going to talk about simplifying the radical on the top and bottom. step 3, we're going to rationalize. Did Mrs. Lacey go over rationalize with you guys? Possibly? That's when there's a radical in the denominator. Okay. All right, thank you. That'll help. And then 4, we simplify again. All right, so I guess let's define rationalize. Make sure we understand what that is. Rationalize. We rationalize anytime there is a square root in the denominator. Okay, which means we're going to multiply by that same square root. Okay, so for example, if I have 1 over the square root of 5, there's a square root in the denominator, so I have to rationalize. To get rid of the square root, can never, ever, ever have a square root in the denominator. We have to multiply by that same square root. Whatever we do to the bottom, we also have to do to the top. So technically, I'm multiplying by 1, because I'm doing the same to the top and the bottom. So on the top, when I multiply 1 times the square root of 5, I get the square root of 5. On the bottom, when I multiply the square root of 5 times the square root of 5, I technically get the square root of 25, which simplifies to 5. That's rationalizing. So you multiply by whatever the square root in the denominator is. So let's say I have 1 over the square root of 11. Then I'm going to multiply by the square root of 11 to both the top and the bottom. On the top, 1 times the square root of 11 is square root of 11. On the bottom, square root of 11 times the square root of 11 is just 11. Okay, that's rationalizing. And you're going to have to do a little bit of that today. So let's talk about that. So I'm going to throw a couple different things at you to begin with. Let's say I have the square root of 2 over 8. We'll start off easy. All right, so remember the first thing I said was to make sure you reduce the fraction first. Okay, so step 1, we're going to reduce this fraction. And 2/8 reduces to 1/4. Then step 2, I told you to simplify the radical on the top and bottom. So we're going to rewrite this as the square root of 1 over the square root of 4. The square root of 1 is 1. The square root of 4 is 2. Is there anything else to do? No, because we got rid of the radical in the denominator. Try another one. Let's say I have the square root of, how about 2 over, 6. Okay? First thing we do is we take the square, or we reduce this fraction, excuse me. We reduce the fraction, that becomes 1/3. All right, now, we break this into the square root of 1 over the square root of 3. Square root of 1 is just 1. Square root of 3, can I simplify that? I can't. So now I have to get rid of the square root by rationalizing. So I'm going to square root the bottom and multiply by the same thing on the top. So 1 times the square root of 3 is the square root of 3. Square root of 3 times the square root of 3 is just 3. All right. Make it even tougher. You have 1 in your homework that is similar to this. Negative, the square root. So that negative's on the outside, right? Say I have 2x to the 3rd over 5x squared. Okay, we have to reduce the fraction first. So I'm going to do a square root. My negative's still on the outside. Start with my numbers. Can I reduce 2/5? I can't, so that stays, right? X's, where do I have more X's? I have more X's on the top. I'm going to leave my X on the top, right? I have one more X in the bottom. So I reduce my fraction. Now I write this as separate square roots. So this is a negative square root of 2x over the square root of 5. These are both exactly the same. Then we look to see, can I reduce either of those? I can't. So I have to rationalize. Whatever the square root is on the bottom, that's what I multiply by. Whatever I multiply the bottom by, I have to multiply the top by. On the top, I still have this negative on the outside. And we multiply our insides together. 2x times 5 is 10x. On the bottom, the square root of 5 times the square root of 5 is just 5. Now you can't reduce this because this is inside a square root. This is outside a square root. So this is your final answer. All right, questions so far before I keep going? How's everybody doing? This should all be reviewed today. Okay, so I just want to put that out there. This is all review. We've done it before. Usually you get a good review from Mrs. Lacey coming into this. And I don't know how much she got to do with you guys, but so let's just do a couple more examples very quickly. How about if I have the square root of 200 over 28? Step 1, reduce the fraction. I'm going to put it right underneath here. Reduce fraction. All right, so what goes into both 228? I know 2 goes into both of them. Okay, so if I reduce it by 2, that gives me 100 over 14. I can reduce that further, can't I? I can actually put 4 into both of them originally, right? So this is actually the square root of 50 over 7. All right, now we're going to break it into 2 square roots. I have the square root of 50 over the square root of 7. Square root of 50, does that simplify? Square root of 50, let's kind of go over here. 50 breaks down into 25 times 2. 25 is 5 times 5. So I can take a group of 5s out. So this top becomes the 5 square root 2. On the bottom, I still have the square root of 7. That doesn't simplify. Now, I still have a square root, so this is where I'm going to rationalize. So I multiply by that square root, whatever that square root is. Whatever I do to the bottom, I have to do to the top. On the top, when I multiply these together, technically you're multiplying the coefficients in front of the radical first, so 5 times 1 is 5. And then you multiply inside the radical, 2 times 7 is 14. On the bottom, square root of 7 times the square root of 7 is just 7. So this is your final answer. Any questions, anybody? Okay, so today your homework is on page 225. It's kind of like a little insert in your book to review before we start solving when you have square roots in your answer. And we're going to do numbers 1 through 16 all. Okay? Some of them go very quickly. You're just simplifying them. Again, remember if there's a negative inside the square root, you bring it out as imaginary. We did those back in Algebra 1. Other than that, the only thing, until we try these, we're not going to know where I need to go from here, okay? So I want to build off of this, and I don't want to just throw you into solving and having square roots in what you're solving until we've talked about this, reviewed it, and make sure we're good, all right? Okay, well, That's all for me for today. Try these 16 problems. You guys are going to do great, and then we're going to build off of this tomorrow. All right. Have a great day, you guys.